Okay, so in this video, we want to finish our small little Plugdata sampler. And this is here where we left in the last video. If you haven't watched the last two videos, please do it now so we are on the same page. So in this video, I want to cover some of the bugs we still have in this patch, and also want to change some things here to the patch itself so it's more pleasant to look at. So the first idea is here that some of these interface elements have receive symbols and send symbols, as you can see on the right side in the inspector. And this means you can send data and receive data without using these kind of send objects here, and also using here receive objects, right? So we can just take this address here, volume dry, and instead of connecting this and that, we just go to the interface element here and put this address into the send symbol. So now we send data directly from this knob to this address vol dry. And everything that uses receive vol dry, like this one here, receives the data. So we don't need actually that object here. You can see it's more pleasant to look at, right? So all we have to do now is here take all these addresses, put this here into these send symbols, and can remove here the feedback, the send objects. So here we take feedback, send symbol feedback, can delete this also here, take this address and send it over here, and so on. Also at the same time, we can use send objects here and say we want to set this to knob dry level. We can take this address here, and then instead of going in here, take this, put this into the send knob, and then we can receive this here with the same address, knob dry level. Or let's go here for the same. I have to work a bit now on my naming conventions. Knob vol dry. Okay, use that. That's a bit shorter. And then we do the same here with, let's say, feedback. So we say here it's knob feedback. We take this address and then put this into the send object. And we can connect here these two. Also length here, s length, knob s length. Put this into the send object. Also connect here these two. So we can kind of separate here these small little islands. We also have here a connection from load bank to the playback bang knob here, which is also an interface element. So we can use here also a send symbol or receive symbol. Let's say knob play. Take this address, send it, connect these two, and we can remove here this small little connection, and we have here a separate thing sending signals to all kinds of addresses all over the patch. And if you do this too much, maybe, then of course it becomes a bit, you know, you lose control over where something is flowing. Maybe we get in the future some kind of hints, some data flowing lines here, so we can see where data is sent and received. Would be nice to have. So there are many more places we can use this trick on. So let's see. We have here, for instance, this metro bang receiving data from the metro. So we are using here a send and call it maybe metro bang. Go into that, and we can say this address here is received with this knob, metro bang. We can delete here this connection. Put this over here maybe. Then we have here, let's say, yeah, this output here, for instance, this line, we can use a send here. We can say this is, let's say, time frame in milliseconds. So we go into that, use this address here. We can use this also on this number, which is also an interface element. So it has also your receive symbol, time frame, and we can just remove this connection here. Also here, of course, we go from here to here, right? So we can take this one, put this over here, connect these two, and delete this, because here is also a receive symbol time frame in there. So we receive data there. So maybe let's try and change the length here. You can see we change the values here, even though there's no connection. Nice. So then we have here the V line. There's the last kind of connection here. So we use a send and call it V line. Connect this here. Choose receive. Connect these two, and we can disable or remove this kind of connection. So we have here an island for our calculations with the sample rate. We have here the load bank for the init values. We send all these init values around to our, or all over the patch here. And we don't need a connection for that. So it's much cleaner to look at. Maybe you lose control at certain points, like I said in the beginning. When you do this too much and the patch becomes too big, then of course you have to use sub patches and so on, but I don't want to do that in this video. Maybe in later videos we go into sub patching. We can also remove these two here when I look at it. So let's use here receive metro bang. We can connect this. That we can remove these two connections. Nice. Okay, we have also this one here, which changes basically the dry volume. Okay, so another problem we had in the beginning was that we, on the last video at least, is that we had some clicks and pops. So here there's no plugin at the moment, so let me use here an piano tech instrument, so we have some audio to work with. Let's go with this one. And let's use here the input, and of course let's use my MIDI keyboard. So now I can play something here. You can hear there's some kind of click and pop in the middle. And the problem with that is that we write and read into and from the same array all the time. So we write into the array from the left side to the right side, right? And then we read from the array from the right side to the left side. And you can see in the middle here basically is when we have this click, because we meet the new recording and the last playback basically. Yeah, it's always here. It's basically here where you can see the new buffer is overwritten, and then we read from the back here, and then in the middle we have this click kind of where these two waveforms meet. And my solution for that is basically that I use multiple arrays for that. So just downsize here this one. And then I kind of copy it over here to a second one. So I just use copy and paste. And this one here is called differently. There's a different address. It's sampler 2. And we still record here basically into the first buffer. And what we want to do is when the write process is done, when we are done writing here into the buffer, I want to copy this whole buffer into the second buffer. And we can do this here with some array read and write modules. So let's do this here by using array get sampler. So this one basically gets here all the data that is in the first array. And we use here a bang knob. That we don't need to use a bang knob, but I use it. And then we do a second one, array set sampler 2. So I can write now into the first array, and then at a certain position I can say copy everything over to the second array like this, and can make a snapshot basically of the current thing here. So then I want, instead of reading from the first array, I'm reading from the second array now. And I want to use the metro bang basically here to do this whole process. So I go into the bang here and say receive metro bang. So every time we bang here basically, we also just copy the first array into the second array. So now it's basically when we read from the second array, we are left alone from the writing process. So the writing process can write into the first sampler every time. And the second sampler is basically only refreshed when the writing process is done for the whole array. And then everything is copied from the first array into the second array. So it's much better this way, in my opinion. Maybe there are some pure data specialist experts that can write something in comments. What would be the better solution for that? But I think it's pretty okay to do that. So then we have this. We also need to resize here the second sampler. So if you can remember from the second video, when we change the length, basically we also need to change the length of the array, the index size. And we do this here basically with this resize message, sending this to the sampler. But we also need to send this here to the sampler 2, of course. So that's that. So this is basically my solution for the clicking problem. And I think you shouldn't have any clicks now in your audio material. Okay, so let's try it again. There's still this click when we copy from the first to the second. But maybe we can introduce their volume fade later on. At the moment, it's better than before. Okay, so let's move on. So the length knob at the moment is in seconds, I believe. It's in seconds. And we want to change this to milliseconds, firstly. And also secondly to for the interface in fourth nodes. So we want to time sync this with the BPM of the host, right? So you have 120 BPM maybe, or 100 BPM. And then these time frames for one bar or for one fourth node and so on changes, of course, with the BPM. So we have to recalculate this stuff, right? And we can do this by using an object called playhead. And playhead gives us a lot of outlets here. can see we get here a 1 or a 0 when the host is playing or in a playback state, or when we are in a record state. We also get here the BPM. So BPM is in, let's say, print here. Is 1 out of 10, and we receive this basically as a number here. When we change this to 90, right, you can see it on the right side, and it's firing all the time. So it's updating, I think, each millisecond, probably something like that. So 1 out of 10 is not really what we need. We need to convert this into milliseconds. In exactly milliseconds for 1/4 node. And we can do this by using an object called ppm. I mean, we can do some math here using just division and so on. But this object here is pretty helpful, so I just use that. So ppm here gives us basically, so you can see your milliseconds. So for 90 ppm or 100 ppm, we get exactly 600 milliseconds. This is 1/4 node. So this is here 1 bar. I think this is 1 bar, right? This is 1 bar. So this time frame here is basically 600 milliseconds. So this is 1/4 nodes. So now with multiplication, we can of course just duplicate this and say times 2, right? And then we have 2/4 nodes, and then we multiply this by 4. We then get 1 bar, the length of 1 bar in milliseconds. So this is the idea for that. Okay, so the first thing we need to do is to change here down here, where we receive the length of this knob, which at the moment is in seconds. So we use here a value between 0.1 and 10. So this is seconds. We send this over to here, and then we multiply this here with the sample rate. So we need to divide basically this by 1000. So we take here a division 1000 to kind of, change the unit from seconds to milliseconds to have this here in place. Then we want to use, instead of a print here, don't need to print, we use a change object here. You can see change is, I use this because I only want to receive updates or messages when something changes, when the BPM changes. I don't want to update here every millisecond. So when we use the print here, you can see here, this is flashing blue, this is flashing in blue, this is flashing in blue. It's getting updated all the time. Only print doesn't receive any updates. Why? Because the BPM stays the same. Only when I change this here, when I change the BPM on the host tempo, you can see now it flashes and updates the value, and we receive data here on the print. So with the change object, you can basically prevent these updates and only let messages pass through when something changes, when a value is changing. When the value stays the same, you don't receive an update. So it's a nice object to use here. So then I don't need the print here at all. And then we need to introduce maybe here a number. And we want to have a minimum of maybe 1. And maximum number maybe of, I don't know, 8 or something like this. So this is basically the multiplicator. Don't know what the real name is for. So how many times we want to multiply basically our 1/4 node time frame in milliseconds. So we do this here with the multiply. Go into that, and we take here the output of the change for that, right? So we multiply basically here the milliseconds times how many times we want to have this 1/4 node. So this is basically 1/4 node, then we go to 2, we have 2/4 nodes, and if you go for 4 here, then we have basically 1 bar. So the time frame of 1 bar. And then we need to put this into, first and foremost, into the interface of this knob here, because we want to change the range of the knob. So we do this by sending something to, let's say this receives on this address. So we go in here, send something to that, and we send basically here, let's use a message. I want to change the ticks to a certain number, and we also want to change the range. So right from here, at the moment the range is 0.1 and maximum is 10, so we want to change this accordingly. So we also send here another message and change the range to start value, and end value. So now we have to pack this here, float. So we basically say what we receive on this input, it goes into the first float, and the second inlet here goes to the second float, right? We pack this together in one message package, and then we send this over here to this message. We then replace here the first float with the first variable and the second float with the second one, and then we basically create this kind of message which has this word, this keyword, and then these two numbers, and then we send this over to the knob here, and then we receive this here, and then we change with that the range, the minimum and maximum number. So this is kind of the idea of that. So the second input here is of course the last number. So the range, the end range, is basically here this multiply. So we take basically here the 1/4 nodes in milliseconds, multiply it by 4, which is 1 bar, and then we get milliseconds as the time frame for 1 bar. And this is the end range, right? The maximum number. This is the second float, so we take this. And the first float is basically the minimum time frame in milliseconds, and this is what we get here from change. So this is the smallest kind of range of the knob, which is just 1/4 node. So you have to always sample 1/4 nodes. You can divide this here if you want to go shorter, of course, but I just use here 1/4 node as a minimum starting number or minimum range, basically. Okay. So we also need to use here the output of that for the ticks down here. And ticks are basically here some interface elements. You can see this in a moment when I change this here, right? 4, you can see now we have these dots here. 1, 2, 3, 4. It's basically a quantized interface element. So we have maximum number of 5/4 nodes. So we have here 1/4, 2/4, 3/4, 1 bar, and then 5/4, right? So we can kind of quantize here the interface with the ticks. So we use this number here for the ticks. We use the number to multiply here the milliseconds for 1/4 nodes, and use this as a maximum range. And then we use as a minimum range, we use 1/4 nodes coming here from the BPM setting. So this is my totally genius idea of how to structure this. But it kind of works. And then after that, we want to receive what's coming from S length, and we don't want to send this to S length. We don't want to send this from here to here, right? We don't want to do that. We want to put a quantizer in between. So we send this here, instead of S length, we send this to maybe length. We receive this data here, and then we put this into a quantizer, and then we send this back out to the original address, right? So instead of instead of going from here to here, we go now from here to here, and we quantize it, go back to here, and then we send it here. So it's just in between now a quantizer. And as a quantizing number here, step value to quantize to, right? We take basically the output here of change. So it's the quantized step size is 1/4 node. So that's the idea. And with that, we want to also save this here just to make sure. Let's say it's now part 3. So we make sure everything is saved. So now that we have this, we can now change here, I think, in different sizes. So let's update here the BPM. You can see here the stepped size now. So the minimum number is 600, right? Then we increase here the number. Then the next one is to 1200 and so on. So we have kind of a quantized number now, which is in milliseconds, but it's always the size of 1/4 nodes, and it changes when you change the BPM. So when you go to 110 here, right, you can see now the numbers are different, but they are still stepped. So this is basically the calculation for having exactly the right buffer size in milliseconds for the BPM you are currently choosing in your host. I know it's a bit complicated, but if you think about it, it kind of makes sense. Okay, so the next thing would be to expose some of these parameters to the DAW for automation and so on. But there's still here some problem we have to solve, and that's here. We basically used to have here seconds, now we have milliseconds, so we don't need to use actually here times 1000. That leads to some kind of problem, so we just need to remove this here, because this is now already milliseconds. So we use this here and time frame there, bam. So that's better. And then we want to expose some parameters, like I said, to the DAW. So we can use here these automation parameters and can say we want to expose your feedback. And if we change this here, you can see it in the background probably. Size this a bit. You can see it down here, right? We have created basically this automation parameter called feedback, and we can use this in the DAW. And we can access this by using parameter and the name of it, feedback. And we send this here to our knob. The address of this is knob feedback. And then you can change the feedback here with the slider and also in here. And I think we can also use the output of this, send symbols feedback. So we receive feedback here and send this to the parameter. That's not gonna work, okay. Maybe we have to make a second one here. I don't know. So we can move this here, but it doesn't move here. This connection still works. It looks like we can't make a connection here from this one to that one for some reason. Maybe if I remove this here, let's see. Yeah, there's no connection happening here for some reason. Maybe this is a bug. Maybe I'm doing it wrong. But I guess in the future this kind of works if you do it like this, right? So we take the output of this interface element, send it over here, go into parameter feedback, change basically here the automation parameter, expose it then here, and everything that we receive here, oh, this connection works. So if we turn this knob here, we can change it here, and also inside of the patch. Okay, so this kind of works. Maybe we do this also here with the wet level. So we send here to volume wet. So we receive this here. Go into a new parameter. Volume wet. And then we send this back to the object here or to the interface element. And we are good to go. So let's see if we actually use here. Oh, we have it already here. So we can automate this. You can see it's updating here the value. Nice. You can also change here feedback. Yeah. Okay, so this is how you expose parameters you create here on the right side. These automation parameters, and then you can use these modules here called param, and then you use the address of this thing here, and then you can send data and receive data from it. So this is the idea about it. Okay, so let's try it out. If it still works here. Let's update here. This one, it's a playback. Maybe increase here the sizing of that. Maybe one more. Yeah, something like this. And then let's see. Size of the plugin, right click properties, height is 370, 375. Let's see how it looks like in plugin mode. I think you have also to expose all parameters if you want to preserve this when you save the project. I'm not really sure, but I think you have to do all these kind of automation parameters for all these knobs here if you want to save it with a preset or with the project itself. Oh yeah, we have to do just one more thing, because the playback is always, or you start basically the metronome here every time you load the patch, but that's not specifically when you hit play, right? You need to synchronize it here with the playhead in some way. So instead of using here, let's say load bang here and then trigger the playback, I want to use the output of the playhead here. So I'm using change and the output here of play. Oh, change. Right, so we receive basically here a 1 when you hit play on the transport. Select 1. So we only pass through messages here when we have basically a 1, or when we receive a 1. You can see here when I hit stop, nothing really changes here. Only when we hit play, it flashes basically. And then we start here the whole process instead of using load bang. So that's probably much better. So now we synchronize basically the start of the metronome, and then all these milliseconds make sense for these 1/4 notes and so on. So we need to basically synchronize the start point or the playback. Okay, so let's save this here. Let's go back to plugin mode. So it's synchronized. The buffer size is the right time frame. We synchronize it with the host tempo, and we also expose some parameters for automation. I showed you in the second video how to use the plugin mode. There are probably some errors in here, and Plugdata is also still in heavy alpha, so there's a lot of changes. Sometimes it also crashes. As you can see here, the interface, it's behaving weird for some reason. So yeah, keep that in mind. And I think that's it for this tutorial, for these 3 videos. There's still a lot of stuff you can do, of course, and change things and make it different. But I want to give you basically an intro how to approach these kind of devices, how to use Plugdata, and how to expose parameters, certain features, right, that you can also use here playhead and get some information from the DAW into Plugdata and use that to react on it, right? How to use these send and receive objects here also with the interface elements. That's very neat. And maybe in the next tutorials I talk about sub-patching and stuff like this. And yeah, I think that's it for this video, or for this type of series. Leave a like if you like the video, subscribe to the channel, and also head over to the Plugdata site and make sure you're a sponsor if you want to spend a bit of money on it, because it's completely open source, it's free. All these guys working basically for free, and try to give you this environment here. Okay, thanks for watching. See you in the next video. Bye.